The power tower was a project that was undertaken by Daniel Hollaar, Tyler Haselkamp, Brady Rud, Isaac Lahr, and Caleb Cross for our senior design project at North Dakota State University. The project motivation stemmed from the overpriced and overcomplicated radio towers on the market. These attributes make them inaccessible to rural areas and less fortunate communities across the globe. Our goal was to design a tower that was simple, functional, and much less expensive.
Selecting a concept was the first step. The only constraints were that the tower must be 100 feet tall, serviceable from the ground, and support 100 pounds of antennas. Concepts varied anywhere from pneumatic to folding styles, but a telescoping version was eventually selected. This concept utilized PVC supports to drastically cut costs and weight. Soon afterwards, a detailed CAD model was created.
Finite element analysis was performed to ensure the tower could withstand the antenna load as seen in this figure, and the drag force from a 20-mile-an-hour crosswind.
The tower was constructed as a half-scale model. First, the PVC supports were glued and drilled using a jig. Next, the steel cross bracing was cut with a shear and drilled as well. It was helpful to drill multiple pieces at a time. Then, the bracing was attached to the PVC with common quarter-inch hardware. The top 4 sections of the tower were constructed with PVC while the lowest section was completely made of steel to provide a solid base. All tower sections slid past each other on plastic guides. As promised, the tower was lightweight and structurally sound. In the final steps, the pulley system was added to the tower. The steel cable was ran through the pulleys and attached to the hand crank on the base. The hinging assembly was mounted on a pallet for temporary testing.
Finally, the tower was complete and ready for testing. Only 2 people are needed to tilt the tower upwards from the servicing position. Then, it's as simple as cranking the tower upwards. It is important to raise the tower in calm weather. Otherwise, a person is needed on each of the guy wires for support. Once raised, the guy wires can be tightened with a turnbuckle. Cranking the tower down is as easy as going up. Our team would like to thank Dr. Azarmi for his advice over the past year and the NDSU ME department for sponsoring the project. Also, thank you to Ready Engineering for allowing us to use their facilities and Derek Bowman for helping us weld.